Welcome back to Cloud Computing and Big Data. Today we have our practical lecture 5.1, Understanding MapReduce in Cloud Applications. And this is a very practical lecture, so we will connect several different pieces we had in the lectures before that were more conceptually actually explaining what MapReduce is, but we also will connect to some practical insights, so how we basically can do a MapReduce in MS Azure, things we already know from previous practical lectures. And then we want to explore another cloud, which is the Amazon Web Services cloud. And we'll basically there also see that MapReduce is a paradigm, as we learned in the last lecture, that is basically also available in different cloud vendors. And we will have a look in AWS and how they actually realize that. But before we go into the material of this lecture, let us review what we had the last time. The last time was really thinking about the MapReduce approach. And immediately when we basically looked at this, we basically connected back to basic 101 computer science in the meaning of divide and conquer approaches. That means we have a very large problem, for instance, looking through a very big pile of documents, maybe petabytes of data. And then we break this petabytes of data down into very much smaller workers that all look at a certain part of the pile of all of these documents, and then in between do something. We had the example of Wordcount. That is a very simple example, but as you remember, also the idea of this MapReduce was really keeping the computing relatively straightforward, so not doing big, number crunches to weather forecasts and so on. So basically here we think about simple occurrence of words, for instance, and just always add a 1, add a 1, add a 1 when I find certain words. Obviously, that's not the final resource, basically result we're after. We also think about combining then this result. Hence, we have the partition and then the combine approach, the divide and the conquer. So the origin of that was much more high throughput computing than basically high performance computing, as I was alluding to with the weather forecast. So high performance computing is rather doing that, having each core really highly interconnected. So in HTC, what we are after is very embarrassingly parallel problems. Embarrassingly means here in this context rather that I have here a situation where basically I can do very independent tasks. All these workers, as you see, don't really communicate with each other. They can work independently, and only the result then at the end is shared with all others. Now, the idea of MapReduce, to share it, is basically then something which makes it so powerful, because I said to you, well, maybe if you want, it's not really map and reduce, it's really map, sort, shuffle, group, reduce. So there is this intermediate step here, which is very powerful, because you have a key value pair structure, where by defining a proper key structure, you have really a very powerful framework that takes away very much work from you, in order to, of course, shuffle and sorting according to keys, grouping by them, or reducing by them, then what we do then basically at the last step here to get to the combined output. Needless to say that this is now working at scale, so you don't really program it in a way of saying I'm doing it for 10 workers, I'm doing it for 20 workers. This is the beauty of this framework as well. So basically all the parallelization, all the communication that takes place here in between is basically hidden from the end users. So people that use MapReduce are usually just interested in programming somehow the map task and programming the reduce task. Obviously also defining a very smart key value pair structure. It really depends on the application problem. But here are very nice elements happening in the middle by the framework implementation that is often overlooked. And by this, we also introduced several other different pieces, which really resiliency and fault tolerance and things like that. That will come back when we also look at the Hadoop distributed file system in a moment. Before we do that, the key idea of basically then MapReduce in the open source implementation is to combine it with many different other, let's say, software pieces that you see here as a big step. One key element is the Hadoop distributed file system that we had the last time as well, where basically you have a really efficient, reliable, and fault-tolerant storage. And how this is achieved is basically, as we have seen, by two types really of nodes. The first one is a head node that you see here with some, name node and knows the metadata. So basically that means you have a sort of manager that knows where is a big file that you see here sharded in. Of course, this is a configuration parameter. You can do here more different parts, but the 1, 2, 3, 4 explains a little bit how it works when you see it in combination with the data nodes. So instead of having one file basically alone and then replicated, you see we have here different block sizes, and the blocks are then distributed on all different data nodes. That also means, given a certain number of replication of these blocks, that basically if, let's say, this node is failing, then we basically able to obtain basically the 2, the 3, and the 4 just from another data node. And this is the idea of this fault tolerant. If you do the map task close to this data and suddenly the whole node fails for overheating, whatever reason it is, could be a network connectivity problem in a switch, then we basically can just resubmit the map task there where the other replicated parts of these blocks are. And this is one of the big power of MapReduce. Also, this is hidden from the user. So this is automatically done, automatically monitored, and this helps a lot. Now, just briefly looking at the big step here, when you combine now the whole stack that you already partly use with Hive for structured query language parts, so really relational database more. You can do small scripts with Apache Pick. You have some metadata management with HCatalog, or as we had in some Facebook examples, HBakes, which is really a NoSQL database. And there are many others where you maybe can combine these kind of key values pair structure with nice NoSQL store like Cassandra, for instance. These are elements which also come later in the course. Now, Mahout is for machine learning and data mining. Also, this we have later in the course, but also builds on the power basically of MapReduce. So here we have implementations in Map and Reduce for machine learning problems, so that you even don't have to implement that anymore. Not so shortly, just for the sake of completeness, Scoop can be also used for relational database, while Apache Flum here is something we look in later lectures also basically to do data streams. And now, if you look into practice, that's what this lecture is about. We can see that essentially this stack, in one way or another, is basically also parts of Google Cloud, parts of Microsoft Azure, as you already know, and of course also the Amazon EMR, the Elastic MapReduce we want to look in today. So, very practical lecture today. Let's look a little bit than what we do with Amazon Web Services. But before we do this, I just give you a short demo also that, of course, MapReduce can be done with HD Insight, as we already know, with our PySpark that we had already used and you use right now for your assignments. Then, of course, Amazon is a very big beast if you want, right? So it has lots of services. This is a very broad service portfolio. We'll look at this a little bit, picking several different pieces out, the EC2 service and the Elastic MapReduce, and connect it with the pay-per-use approach that we have, essentially showing you that the cluster costs, of course, depending again on the power of the CPUs, the basically available memory, as you already know, which is quite significant for Spark. Now, a bit unique here for this is also the idea of key pair generations. I will basically show you a little bit how that works in practice. And then we look just briefly at the end of the first part to the marketplace and, of course, some bigger application examples where you know where this is really used. Then in the second part, we want to understand here and there a little bit more how now MapReduce works in the AWS services. So here we have to have some dependencies to the EC2 and key pairs explained. And on top of that, we will create an EMR cluster. Obviously, there we have just compute. So we have to think a little bit when we have an application like Wordcount, where are actually the results? And so we have to also create a so-called S3 storage that basically then will capture all the word count results. And I show you how that is done. Basically, then there's a very specific form, basically also how you can use AWS, which I want to show, which is a little bit more a streaming approach. While we, of course, connect to the idea of having Jupyter notebooks, and that is working nicely also in AWS, like we had in MS Azure. Here's also a built-in aggregation idea, basically how you can really very easy connect to MapReduce implementations and also have your own ones. So usually, of course, you have to implement MapReduce, let's say in Java, for instance, and then have a jar that you can basically also there use. Here we use one example in the space of word count. Again, just another way how you can actually do it. And then, of course, at the end of the lecture, also look and review in the larger MapReduce ecosystems for applications. So let's see and connect a little bit what we had the last time. I will not largely talk about this because basically we have just had this in the last lecture. Just take away again what I said with this group shuffle sorting. So especially if you see that when we program this, it's almost always an one-liner, basically. And this means you can take the output directly in Python, very nice, with a dot, and then basically map it, then reduce by key and so on. So basically you have a very nice way of implementing it. Take away the message that, of course, underneath the framework is really using parallelization, getting the data out, and so forth. So something like when you have a real big installation of Spark is, of course, then harnessing the power of parallelization. And also here, I said already, what we're going to use today is basically Hadoop, but also you will see that the kind of MapReduce implementation is available in Spark. So in the first part, we will also leverage this a little bit and just look at the very simple problem from word count again, and how this is actually now finally created in practice as basically connecting to the things we already know. And as a simple example from terms of applications, I brought you again the food inspection. Now this time we're not interested in any machine learning. Here we have some README that is a little bit about that problem. So here we're interested in just looking at the metadata and counting some services. In the assignment related to this, of course, there would be a little bit an interesting twist when we think about that we want to maybe do this with violations, but this will be then another part of the assignments. So word count itself, we have seen is a very simple problem. And of course, this is the key idea of this MapReduce cluster, as you already know. Here's the idea that we have this big number crunching. So you see, we basically have a task with lots of basically data coming in, could be even streams of data. But of course, here we think maybe as an example of petabytes from some data. Then we would map this with a certain key. And of course, for us, a key means now basically here the idea of going through all the documents and counting then basically the document content. And what we want to do is really the idea that this key should be a word, right? So basically this thing, what we can get out of that is just a simple occurrence. So I will always count one when I see each word. So this is not, let's say, a very big problem, right? So this gives us a long list of words, as you have seen already in the last lecture. And then basically the beauty is that this framework is now basically based on these keys, doing all the different sorting, shuffling, and grouping that we have seen between all the different nodes. So we basically here now have a long list of basically per node here of these words, which always say comma one, word, comma one, word, comma one, word, comma one, etc. So basically all these different words are then here distributed. And what we have now to do is basically bring them together and grouping them by key so that we have at least all the words together. However, they are not added yet to one final output value. This is something what we implement here in the reduce key, where we basically have here now for each of these basically keywords, which is always 1, 1, 1, a list of these counts, so to speak. We go through this list of counts, and then you see here very simple also add, of course, just add operation, essentially getting us then finally basically the result. Also, this is of course done then in a distributed fashion. So we need still to combine all the output then from all of these different reduce operations to have then the combined output, usually written also to file. And that's what we will do now a little bit when we come back and connect to our MS Azure. So here we already are in the space of the cluster that you already know. Here we basically have the Jupyter Notebook, as you also know from your assignment already. What is new is that I basically have provided here a MapReduce Python notebook, implemented this very quickly, basically just to show you a little bit, essentially an idea how you could program that. Here it's better to, as you know already, probably also from your assignments, to restart and clear output so that we're really connecting again to this kernel here in order to get then also to a Spark session. So this is something basically coming up. You see kernel created, kernel ready, and now we can actually work. So you see also in my simple application, I don't care about machine learning here, I don't care about structured query language and things like that. So that's why I don't really need to import all of that, right, that we had from the last lecture or from your assignment, where we, then do and use this Apache Hive and SQL and basically also then the machine learning library, a little bit of Spark for logistic regression. Here, I'm just interested in basically creating the Spark context. That is very similar, as we know already, of course, from our assignment and basically from the work before. We need the Spark context, basically the Spark session that is just starting there in order to basically tell Yarn, now I want to have a distributed computing program. And then Yarn is basically now in the back scheduling this. Hence, some of you in the assignment probably will get no resources right here and have to come back in 10 minutes because Yarn already scheduled it for maybe other students. And as you know, a teaching cluster is not as big as a real production cluster just for the money purposes. So this is something, of course, to take away already. Now, while this Spark session is basically starting up, we just can also maybe briefly review a little bit what I just told to you from the cost perspective. So let's go a little bit here to the main Azure page again, where you see maybe the cost management and can already basically see a little bit how much money we actually already used. So you see here different subscription models, and the one we use here for the course is pay as you go. And we have already basically 246 euros paid. Now, this is not much for a startup. That's not much for a big industry, but accumulates, as we see, right? So from the beginning of the course, where we basically started with HD Insight, you basically see a very nice breakdown and actually also a forecast of the cost. But before we lose again the Spark session, let's wait and see. We got now here basically the Spark session available. So basically the Spark session is now available as Spark, and the kind of Spark context that we need from our previous implementations is finally there. That's very good for us. So basically this is finished. And then basically what I did here is just using the inspection data that I had from the application here, the README file, which was just a text file, which is easy accessible. As I said earlier, also, this food inspection example is already uploaded, so that's quite nice to work with. And then you have a very simple idea of how you do this here in terms of basically the word count. Now we see again the problem we had before, queuing. Maybe I was again too long in the other one. It's a common problem that we already see now from basically working with it. And something when you do a real production application, you really should check if you cannot just configure this somewhere, how long basically this time is. There are different configuration models that we will also see in the AWS space. Basically, when we come to then the Amazon Web Services as well, where you basically have then an auto termination time. Here are several configuration parameters that also can adjust this. So basically something which should be considered to going to a production. Now let's start the Spark application again. For us, it's not a big problem. We do teaching and talking a lot in between anyway, which is here now the idea, of course, also to do that essentially when we talk here about some small demos. Let's wait here a little bit. It's always the fun of doing an interactive demo while you're basically in class. Right. While we basically wait a little bit here, I explained already is the idea of the MapReduce maybe here in the code. So as I said, we have here the HDI samples with the food inspection data. So we get a real text file, doesn't matter which one. In reality, you maybe would have a petabyte, of text somewhere getting here, maybe even with a data frame. Here we're using RDDs. Basically, we just got that out of the text file from the Spark context. And once you have this, basically you start off breaking it down into this kind of idea that you split it line by line. And this is something then that you directly give as input, right? So that's what I meant in the beginning when we said the one-liner. Here it's definitely something which is interesting for us because you see quite nicely that here that this output of the line-by-line split is directly given as an input to the map function. Then the map function, on the other hand, is something which we basically see directly is, giving us an idea of doing a map word by word. So as we discussed, so lambda is a function, right, from basically earlier when we had Apache Spark. We remember that we can define a function that means every word that comes in here in the map function, what we should do with it. We basically have a function that just basically outputs word, 1. That's what we discussed in the previous slide, right? So here we have then the map function where we count each occurrence. And basically what we do is just 1, 1. So if I have the same word, it will be also just 1, 1. And this will be a long list that we basically have generated there. And what we can do then with this long list is we reduce it by the key. The key is here the word, obviously. And then basically define another function. And of course, obviously what we want to do if you have 1, 1 for all of these keys, we want to have a simple add operation that we defined here with a lambda. You see basically lambda x, y. What we do is just basically do a simple addition. And then you have a simple output where you collect the parallel output here, basically with a collect operation. You see now the executors are running in Spark again, in order to basically then get us the results of this map and reduce operation that we have seen here. Very simple, and the interesting part of it is really it's a one-liner, right? Now this would be scalable. So if you have now many workers, this would be going much quicker. If you basically have a terabyte of file, this would be basically crunched into smaller parts. And the beauty is you as a user don't really see that. Right? And in high performance computing, when you have message passing interface, OpenMP, and other parts, you have to much more think about this. It's much more, let's say, a little bit more complicated to really do parallel programming. While here in this course in cloud computing with Spark and so on, you see it's quite nicely hidden. And we get the result here from the word counts now accumulated. For instance, data seems to be often in this, which is kind of logical. We would say we also want to have a city of Chicago, as we know, so city is often there, etc., etc. So, of course, this is not the biggest smart file. In other assignments, people do, for instance, Da Vinci and look at some of the books from him. So still capture the message that this is a very simple MapReduce operation. And the same way, basically, as I said here and described it, I already described it also in the slides for you. There are no surprises, basically. So let's go ahead a bit. What is basically AWS doing in this area, right? That's now interesting. We have seen MS Azure can do this. Okay, so what other services exist in cloud? And of course, nothing prevents us to continue with MS Azure, right? But let's say we also want to explore a little bit in this course how other cloud vendors are doing certain approaches. And as I said, the Hadoop ecosystem is a very, very important cloud approach. So we have to look at this. You see a little bit how that works in the Amazon EMR, which essentially is a very, let's say, comparable service that you have seen in MS Azure HD Insight. Again, you have basically an EMR idea of creating a cluster, as you have seen, a Spark cluster, Hadoop cluster, basically your open source big data framework. Important is, of course, the versions. We will touch on that a bit more here in this, which I like also to show you in Amazon, because that's quite complicated if you want to do it your own. If you want to set up a cluster, with all of these different versions of open source tools and basically frameworks, you will see it's quite hard to find the right versions. And in Amazon, you have this given. You have a nice setup of versions already existing and backwards compatibility, which is also a point we will discuss. We also see that, of course, the cluster here cannot fly just right in the cloud. We need something grounded, so some real metal. And this is what we do with Amazon EC2. Obviously, that is a virtualized version of a CPU and GPU, etc., as we already know from using the concept of virtualization here. But basically, we leverage, of course, that there's in the end some physical infrastructure behind it. And also nice on Amazon is that many services work together. While Amazon EMR is basically this construct, we see later in the course the Amazon EMR Studio or even SageMaker, which is for machine learning, which can nicely connect to actually the execution engine that we create here with Amazon EMR. But let us focus first on the MapReduce idea on Amazon EMR before we come then to this higher level services, as I might call it, and then get an idea how that works. Now, when you want to do this as a student, there are some problems. As usual, these clusters are not so easy to get as students. Basically, you see in the Educate from 2020, I think we had teach this until 2020, we have teach this in AWS Educate. Suddenly Educate was transforming itself to a more, let's say, comic version of introducing to cloud computing, which is, in my opinion, not relevant for the course and also doesn't really touch on the services really. Alternatively, the AWS Academy was actually created really touching on cloud services, but this is more in the idea of certifications for industry. So it has been very much benefits for institutions, students, and so forth. But here the problem is that we cannot teach a whole course on Amazon, right? We basically, as a university, want to have and maintain neutral approaches to cloud. So here we'd really want to also have MS Azure alongside actually Google Clouds and AWS as just one example. Hence, it's not easy to get an EMR service. Very similar as you have seen in MS Azure. Also there, we don't really get this thrown after us. So it was basically why we are sharing how you solve the assignment right now. And we have to do the same thing, unfortunately, again, when we do this essentially with our example right now. Although we are in the AWS Academy, and for future cloud courses, we may look into this a little bit, what we can do with maybe machine learning foundations and getting a certification for students on this. But this is something where reading courses might be much more available for some of you which are in the advanced studies, right? Then we can talk about this, getting a reading course in combination basically with kind of these different parts. So as I said, a little bit sad in the sense that this is not part, even in the AWS free tier. So you basically have 4 approaches in Amazon. You would say when you want to have this Educate Academy, as we said, no option. The free tier is always a nice option for people starting. You see, even you can start these days with $300, and it has quite lots of services for free. If you here go on the left side, filter it a little bit and have a look. It's quite impressive. You get quite some hours, also from the storage perspective and so on. But of course, take away the message here is the idea also a little bit of, hooking you in the cloud. And once you're there, you will pay and start paying when your 12 months free, for instance, are over. Then, of course, everything starts charging. Also, sadly for us, in the field of MapReduce, the free tier doesn't offer Elastic MapReduce as part of the free tier. Also, some other hiccups if you basically in a startup and let's say have a long time not used the service, you terminate it. Basically, have really, let's say, get rid of this particular account and want to restart it again. It's basically not possible so easy anymore. So even with the same email, you have to contact AWS support. It's quite a hassle, to be honest, to reactivate. So you better use another email address. The benefit is probably you get another one of this $300. But for us, it's also something where we have to use, again, the usual pay per use. So basically swiping our credit cards. And then here we go. So let's look at this a little bit more from the practical side. Of course, we basically see, and I think we don't need this anymore here from the Azure perspective, but we need the AWS services because it's also a very nice idea of looking what's really behind AWS. It's really sort of very impressive in the terms of really having lots of services available. So this is a jungle, if you want, right? I think hence the Academy of 2 certifications and these different services are really helpful in one way. Just for university teaching, I think it's not really appropriate, rather for industry, for workers really going there. So you see here, very similar setup like we have in MS Azure, different topics where you would find different services to find yourself around. There's an all services part where you basically can now scroll and see every little service that is available. Here you have, for instance, the Elastic MapReduce, the EMR, which is this managed Hadoop and Spark framework that is existing. And this is what we will look at, but you see quickly, it's a lot of different services, and many of those work actually together with some other services, and we will connect some of them later in the course every now and then. One example is that the EMR, for instance, is connected with the EC2, which is the Elastic Compute Cloud that you already know, essentially just servers, and you have to do something with it. And how we use it is essentially then putting the Hadoop framework on it. Now, this is all nice, and basically, of course, the message goes, whatever you do will basically also require you, basically your credit card to be charged. So before we start with EMR, however, we have to look a little bit at how Amazon is working in this area, which is a bit different than MS Azure. Basically, you see here the things that I already demonstrated you. And also just the underlying costs, again, is very similar like MS Azure. Of course, nothing is for free, especially if you're doing a MapReduce service and EC2. You see quickly that you want to have, of course, high memory, right? So they can basically in the instance types from EC2 pick which ones you want. Very similar like we have also done in MS Azure, right? Where we basically pick the different ones. Here you see the general purpose examples for $5.50 per hour, but of course here you go and has just 512 gigabytes of memory. So if you want to really have a good, let's say, cluster and still, let's say, 128 cores here available, and you want to have really proper memory, then of course here you go, you pay $26 per hour. And this shows you again the point of pay per use. It shows you the flexibility you have. And of course, also on the other hand, the danger you have as a maybe smaller startup, when you have a very big Spark cluster that you need, suddenly these costs can really accumulate. And as I've said also earlier, just to reconnect to this, even if you don't use the cluster, if the cluster is running, the MapReduce engine is running, so Spark or Hadoop is really running on it, you have basically configured the cluster, actually it is accumulating the costs without basically being used, because you use already resources and the MapReduce cluster is just ready for you, right? So basically you can ready use it 24/7, but if you don't, basically that's your own problem, because you have deployed it, you actually occupy the resources that basically you have bought in the one sense with this pay per use, although the use, so to speak, is not from your company, but you use it from basically Amazon. And this is something which is sometimes really a trap where some people move to. Now, basically how you connect now to this idea where I said Amazon EMR is a very high level service, so to speak, we need to connect to some proper metal. So the EC2 virtual servers could be with, basically multi-core CPUs that we want for deep learning. We would probably also want to rent some GPUs that we will see later with AMI and in the deep learning part. But let us stay here with the CPUs. Here, the point is that before you even do this and can connect this easily to this EMR service, you need key pairs. And in the second part, we will connect then the EC2 with the EMR and we'll demonstrate that. But here, the first thing is to do a key pair generation. A key pair is nothing else than giving you access to a host. You see here a little bit how that works. You have a private and public key, both at your disposal. The private key is something which never leaves your computer. where the public key is uploaded can be, given around. So basically when the EC2 then basically create instances, you can always use a public key in the cloud, and you can, check if it's really you by having just the only private key that matches this public key. Hence, we will demonstrate that a little bit, how that works in Amazon here. So we basically go to services. We have here some recently ones where I just looked already in, obviously. Then we have this EC2, where we basically have now the virtualized service available. We could launch instances here by different, let's say, types of operating systems, as we already have alluding to. You see that here a little bit: Mac OS, Amazon, Ubuntu, Windows. We can define which architectures, etc. Of course, instance, what I'm talked about is, which basically CPU now. But what you would have here is just a virtualized server. So on top of it, we have to do something with it. What we do also later. Here we're just interested in the EC2, not from a launching perspective, but firstly thinking about which region I want to deploy, which is important because the keys are just working in different regions. So when you do your assignments in Amazon and so on, please make sure you always are in the same region. So when we go now here to see something like key pairs, as I was saying on the slides, you see I already have here a very old key actually, which is essentially an old one from an old course. And here you see a new key pair I just generated essentially here. And when you do this, you can just see it's very simple: create key pair. You would say Morris, cloud computing, big data course, new. You say which basically algorithm you use for this, and you save basically then in this format here, the private and the public key on your desktop. As I said, it should never leave your desktop. So hence, when you created it, you usually download this new key so that you can later maybe SSH into it, perhaps to connect. SSH is a protocol now where you can basically then use your key setup to get direct access to the EC2 services. And you can use different tools for it. MobiXterm is an example what you can do. And then you can use a key and access really directly the instances and can do something on it, like installations maybe of some sort. We don't do this here in the course because in the end, we are interested much more in the EMR that should be on this virtualized resources, right? So we don't really want to intervene with a low-level installation, but you can do that by using the SSH key that we have basically just created, or that you see here on the slides for you as a reference. So this has been done before you even think about the Elastic MapReduce, before you even think about creating this EC2 instances. When you want to explore this, I would recommend MobiXterm. I think by now, after many years of teaching, I think it's the most powerful SSH client. Obviously, Mac users, Linux users, we have already SSH clients here and there integrated or use it perhaps already. So please feel free to also use them when you explore that. And before we stop, just thinking about as a motivation that, of course, many companies use that for much bigger installations. And if you have some time and interest, I would encourage you to go to the marketplace where people that, or basically industries or SMEs that have used MapReduce also, so to speak, resell their approaches, right? Or other companies, consulting companies, basically give you an opportunity to see what the products they use it for in the clouds. And this also has, of course, some MapReduce elements. So there you can see how other people use MapReduce. Examples here that we had already discussed basically is a startup company, Airbnb, in the past. Startup is now a little bit funny if you think how successful Airbnb has become in the last perhaps 5 to 10 years. And of course, how they scaled up from a startup to now a multi-international company. They basically used lots of these EC2 instances for applications, load balancing, and so on. And they also used Elastic MapReduce with 50 gigabytes of data, but of course daily. So this is where you basically the Apache Spark cluster comes into play. Of course, you remember when you have an Airbnb apartment, Airbnb gets some share, right, from your revenues of putting your basically apartment in Airbnb, and that's a business model. And from these shares, of course, they also partly finance than the Amazon EC2 instances and EMR and so on. Same can be said roughly about Spotify here. The context is more rather on the Amazon S3 that we will also discuss in the second part today. Basically a storage, a very simple storage where you can have, let's say, some flexibility in terms of storage of all the different songs that Spotify is basically offering, what you can imagine. And this is something here and there we will come back to these applications, to these known ones, but also we'll introduce new ones in more lectures like lecture 8 when we think a little bit more about infrastructure as a service. Because what we just did was basically thinking a little bit about the infrastructure as a service level. Now that is not enough for today. On top of that, we want to now have MapReduce in the cloud, and that is what we do in the second part of the course.